So meanwhile, I had a little doubt from the task 4. Not
Yeah, yeah,
doubt, but it's something I didn't quite get very well, like
yeah,
process
yeah.
management. Like,
Yes, yes.
uh, can I share my screen and you guide me through it and
Yeah, yeah,
tell
sure,
me?
sure, sure,
Okay,
sure.
screen. And I hope it's visible right now. So the first
Your
like
screen
come.
is not visible now. No,
Oh
maybe it's only for me. Other people can see Prakash's screen.
no, sir.
You need to again share your screen.
Now it's visible.
Oh, now it is
Okay,
visible.
cool, cool. So like in yeah, I gave this command of PS. Like
Mm-hmm.
so, are there two processes over here? Like one is of bash and the second, like, or I should see more of them. Like, am I
See,
in?
just yeah, I'm saying just go to your browser. Open your browser.
Okay,
Okay. Now you can browser is open.
yeah, it's opening.
No,
Or I should open some other application clock. Yeah, so now I have 2 to 3 tasks.
browser open.
Yes, sir.
Now just search over there ps command in Linux. You'll get
Okay.
a lot of extra identifiers there.
This kind of command I was getting, and okay.
See, it has given you all the basically identifiers like dash d, dash
Yes, sir.
t,
Yes,
and what
sir.
is the
I went
meaning
through
of
them,
those?
but
Mhm,
like to kill the processes,
mhm.
uh, like if I enter top, okay, so
It will
okay.
give top command
Mm-hmm.
will give how much process, how much memory, how much other resources are being used by
Used.
that particular process.
Okay, sir. And to kill any command, I guess kill and then that PID of that particular process.
Yes, PID is process identifier, unique identifier for each process. That
Yes,
is.
sir. Yes, sir. And nice and re-nice the changing of priorities.
Yes, that is
So
nice and re-nice works over at level. Kernel level.
okay.
It will change the priority of the processes at kernel levels. So there and nice and re-nice, you need to change some sort of what I can say files. You need to change some sort of configuration files on kernel level so that you can give the access to nice or you can restrict the access from nice itself.
Okay, sir.
Not very hard things. Basically,
It's
if
not
you
hard.
Google, yeah,
I just didn't implement it in this manner. Like I don't know, some I did wrong or what. In front of you, it worked fine.
so most of the people have written or we have yes, cloud networking protocols, IP address, network gateway, Linux administration. Gautam, what is Convo on Linux? CONVO.
Sir, sorry, short form for conversation only. Couldn't help the shorthands.
I have not heard of this particular technology like Convo. I have heard of Cognito. Cognito is there in AWS world used for user management. But none of Convo. I thought I need to learn something from Gautam.
Edited, sir.
Helped
Made it discussion on Linux and variants.
perfect. So whatsoever you have written, all the people, tell me frankly, have you got the basic understanding of those subjects, or still you are confused with these things? If you are confused, we can always discuss on this. What the basic understanding, all of you. The
Yes,
purpose of mine to ask you to write the things whatsoever you have gained is to get what you people have actually gained. Basically, if someone has written a VPC public IP, so those things will come into his mind only whatsoever he had gained or what concepts he had got crystal clear. So he'll be writing those things. So this was the purpose of whole exercise. All of you have written the things whatsoever you got in the previous sessions. Let me
yes,
see,
sir.
I believe most of the people have written. I got Ish, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 17 replies. Still, I believe we have 22 people leaving Krishna Veni and all. I believe 3, 4 people have not written. Been got by them. Okay, just take your own time. You can always edit the things once you'll get in your mind that these are also the other things what we have gained in the previous sessions. Just edit it out or write it out in the other free time itself. So now let me share my screen here. My screen is visible now.
Yes, sir.
Okay. Today we'll be going to cover the basics of data engineering. How many of you people know the term data engineering and what data engineering relates to? Anyone from your side?
So good morning, sir.
Yes, good morning.
I think, I just know a little bit about data engineering. Well, data
Yeah,
engineers they generally take data, analyze it, and reframe it in such a manner that data scientists can use it in a way uh, use it in a business and to get insights from data to convert it to the useful manner. So,
uh, yes. Go on.
and these data come from various places, from websites, from databases, from a lot of places. They generally analyze those data by cleaning it, by reframing it in a such manner, so data scientists can use it. And that's all I know about it.
Good. Very good. This is basically the core of data engineering. If we, in one word, if we need to substitute the word data engineering or data engineer, it is ETL. ETL means, ETL means, and if you know what ETL is,
Yes, sir. Extract, transfer, and load.
load. Yes. ETL means extract, transform, and load. The basic purpose or the basic a task being given to data engineers is to deal with big data. What big data is? Big data is a data which is produced in huge quantities. Likewise, in my laptop or on my desktop itself, I need to deal with files of data which may be up till what I can say few gigabytes of size or so. Because in my laptop, normally I have a hard drive of 1 terabyte over where I store big files, like mostly the big files will be some sort of movies, may it be 4K movies or so. Those will be huge files or so will be residing in a laptop. But in real world, there is a lot of data being produced every fraction of second continuously. And those particular data are being produced by IoT devices, by produced by transactions being implemented in banking sector, transactions being implemented in e-commerce sector. So huge data is being uploaded onto social networking sites by the users, may it be in the form of videos, may it be in the form of images or other sort of text. Huge data is continuously being created in the form of emails, in the form of messages. So when I'll be messaging some other person, the size of that particular message may be in kilobytes itself. When billions of people are communicating to each other, the size will then be substantially big enough. The companies who are responsible for those messaging applications, may it be, you can say, Facebook messages or some sort of Telegram or any other sort of Instagram and all, they are handling petabytes of data. So the data of the scale petabytes is called big data. Okay, now you understand what big data is. The database size of Airtel Payments Bank, what is being served by our organization actively, because Airtel Payment Bank is one of our clients, the size of their database alone, which is holding the transactions of the customers, like banking transactions of the customer, the size of that database is approximately 1400 terabytes. 1400 TB of data. And those database basically are just, they don't have any pictures or large files in them. They have just rows and columns of data. Means the transaction of amount this is done by that person on that date. Just text data, which is stored in some database, Oracle database, in the form of tables. Okay. So normally a int, you know the data structures now, integer, you know what string is, you know what char is. Any one of you, just if you can explain that what these terms are: int, var, char, integer, string.
These are data types of various bits, like integer
Yes,
for 4-bit, and char, I suppose, is like a bit larger, but it stores
yeah,
characters. And
perfect.
likewise, there is long int, double, and
Per-
strings
Perfect.
store like whole words.
So the point of this particular question was to get you informed about that all these data structures have fixed size associated to them. And the size of that particular data structure is no more than 458 kilobytes, maybe bytes or so, I can say, not kilobytes, in bytes itself. So actually, the data is very, very small. Single row or single transaction data is not that huge enough. So you will be astonished to know that in those databases of Airtel, we had stored multi-billion transactions. They are being storing multi-billion transactions each couple of days. That is the scale of transactions. And they are storing those particular transactions from the time over when they had started the business. So the whole data accumulates to a very large size. Maybe individually the data is very small, but stacked up or piled up data will be like of the scale of terabytes. And this database will not be going small in near future, it will be piling up. Like on every day, they will be gaining few GBs of data transactions. So that will add up. So this particular sort of data is called big data. So now there are various different types of data what we deal with. One is structured data, another one is unstructured data, and third one is semi-structured data. So depending upon what type of data we are dealing with, the location to store that data will change, and the terminologies will change. For the fancy terms, what we will be stumbling upon in the near future, or what we will be listening on to in the projects itself. How many people from you have heard of this data lake or data warehouse? Anyone?
Sir, I've heard something about data lake that these are categorized data. Sir, like I was studying about a company like Atlan and Snowflakes. These are companies that
Yes.
deal with data lakes and
Yes.
basically provide customers with sorted and categorized data that is labeled more sort of using big
Okay.
data sitting at the bottom. There are these sorted structured data lakes. This is like just a tip of it. I know heard
Yeah.
of.
Now to yeah, sure. Now to clear you people about what these particular things are, what these particular terminologies are, and how they'll relate to each other. To start with, just we'll think upon a laptop as a data storage medium. So in our laptop, what we have a hard drive over which we have some sort of file structure, and on that file structure, on that particular directory or folder, we put some sort of files. This is how we store our data inside our laptops. Small data.
Yes, sir.
Now, when the database or data actually may be structured, unstructured, or semi-structured, if that particular data is of huge size, then we need to have different sort of storage structures to deal with it. And those storage structures will be, if we'll be using AWS or cloud, they'll be, you can say, infinitely scalable. Like we can have uh, elastic S3 bucket, or in Azure itself, we'll be having blob storage,
Yes, sir.
or
Azure blobs.
yeah, Azure blobs. And afterwards, we'll be having Azure Data Lake V2,
Yes, sir.
this sort
Gen
of thing.
and storage Gen
Gen 2.
2.
Yes. So we basically will be dealing with these storage systems to store our big data. Now, you know what structured data is?
Label data.
They have to defined row and column.
Yeah, the data which will be stored in tabular structure or in form of rows and column. To be very in layman's language, we can speak of like this, that the data which is stored in databases in row column, may it be relational or so structure, it will be called structured data. In some instances, we need to clean that data also, because some sort of null values and other sort of problems normally will be in the structured data itself. So for that purpose, we will be having transformation layer in ETL. So that we'll be discussing afterwards. So now the point is structured data is which is formed in form of rows and data. What is semi-structured data?
Like JSON files, HTML files are the
Yes.
semi-structured.
Exactly. JSON files, XML files. The data which is stored in files, but there must be having some sort of markup in that file. Like in XML, extensible markup means if I want to retrieve a particular bit of data from that file, I can be able to do that. Like in JSON, we can retrieve a particular data stored in a JSON file by using the markup. Okay, that is called semi-structured. What is unstructured data?
Like audio, videos, text, image, etc. are the
Yes,
unstructured data.
exactly. The what data which is not relatable to each other. Like we can't relate the pictures to one another until and unless we label it out for data training or model trainings. Until and unless we have meaningful relation between them, all the blob data stored in blob form will be unstructured. May it be videos unrelated itself, or may it be photos or audio files or anything. Okay, I had written all these things because I have one problem with me that I have a short term memory. So that is why I normally write the things off, so that I may not forget to what to deliver. So now the thing is, you are now clear with what different types of data, what big data is, and the third thing is how to deal with that big data. This is big question. We know where we need to store the big data. That is not. Now you will be aware of terminology, data factory. I'll be giving you basic knowledge of big data is okay. Data cleaner, I'll be giving you a bit of knowledge. Schemas. Any one of you have heard of the Parquet file? What Parquet file is? No. CSV.
Yes, sir.
What is CSV?
Comma separated values.
Okay. Comma separated values. Basically, this file will be holding normally in a database world a transitional sort of row column. Normally, we put the data into CSV files which can be absorbed by some sort of database. This is normally in the similar fashion. There are basically two sort of databases like storage structure underlying in database. There are two types. One is row oriented and another one is column oriented. Any one of you heard of these terms, row oriented data storage
Sir,
or
Yes, sir.
column
Parquet
oriented?
is column oriented.
Yes, Parquet is column oriented. That is why before Parquet, I am coming on to this uh, terminology. So you know what is the difference between row oriented and column oriented database structures?
Column oriented, I think we use in data warehouse. So both are for the
Someone is speaking good. Who is speaking column oriented is used in data warehouse here. This is normal case. And row
both are for
oriented is,
retrieval and storing of data, but they are different
yeah,
technology.
that is fine. Both are for retrieval and storage of data.
Yes,
Row oriented column, yes, no doubt, column oriented is mostly preferred in data warehouses. And where row oriented is preferred?
SQL and
In relational
yes,
databases
relational databases, sir.
dealing with
Traditional.
dealing with transactions.
Yes, sir.
Whatsoever data base dealing with is dealing with transactions, individual singleton transactions, will be preferring row-oriented data. And whatsoever will be dealing with business intelligence, data analysis, those particular or data visualization in the larger perspective, those will be using the column-oriented database. Now you know the basic difference between what's column, why these are being used in different use cases. So what is the underlying thing, column oriented and row oriented? Reason behind that?
I think these are used for analyzing, as you told about that uh, row. I mean, row oriented data are used in data analysis and data visualization. So these are
No,
in
the column oriented is used
yeah,
in data visualization and all.
yeah,
Row
column
is
oriented.
for, yes, yes. Go on.
So data visualization uses column oriented data. So in this, we usually takes data and we train, or we say, I have done exploratory data analysis. So in which I have taken CSV file, which is in column oriented data. Uh, we take it to analyze data and uh, print uh, pie charts, tables, and these sort of things to get
Perfect.
insights.
Now coming on to the basics. How in a database data is stored? It is stored in form of
Tables.
in this form. Actually, in a database, the table is like that. These are columns and these are rows. So understood? This is how actually data is stored in databases. This whole structure is called table, and these are rows and these are columns. Okay. Row one is normally transaction. Let us take an example of a bank database. Here we are storing the identification, customer ID of a person, may it be 240, name of person, may it be Prakhar, and mobile number of the person, may it be something, something, something. This is how databases work normally. Let us take another column over here is withdrawal. Withdrawal is 24 rupees and total left. May he have 200 rupees left in his account. So this is one of the things. This is how actual banking database will work. Now, what this row is a transaction. When Prakhar will be taking 24 rupees out of his account, then a transaction will happen in a core database. This is very, very raw structure of data. In actual banking databases, there are way more fields. The schema of that particular database will be rich enough and it will be having multiple tables related to each other. That is why we call it as relational database. Okay. To have the basic understanding, I am taking a very, very rogue example over here, which means if a normal transaction seems like that, Prakhar has taken out 24 rupees out of his 240 rupees and left is 200 rupees. When he will be taking out 24 rupees, such sort of transaction will be entered or will happen in a database. So a new row will be added in transaction. That 24 out actually is okay. You know this, all people understand. Now, these are columns, means name, ID, number, withdrawal, and left. And this particular row is a transaction. Okay. What row-oriented database means is actually in the hard drive, anywhere over which the data is being stored. Basically, database is being stored in some sort of file itself in a hard drive structure now. So normally the row-oriented databases store their data in some sort of delta file or so. No, for easy understanding, let us say it stores its data in CSV format on some underlying hardware, maybe. So in that CSV file, what will happen? A new row of these transactions separated by comma in a new line will be added. Fine. So what will happen? A file will gain few of the kilobytes or few of whatsoever the data will be added in this, but the data will be added in a row form. A new line will be created with these things. So in this row-oriented database, the actual data is being stored inside the hard drive on some files in row structures. Means first block of hard drive will be having this block of hard drive will be having first column, second column, C1, C2, C3, C4, C5, C6 maybe. When all these things will be done, the next byte of data in the hard drive will be having again this is row 1 maybe. This will be row 2. Afterwards, C1, C2, C3, C4, C5. In this fashion, actually, sequentially, the data is being stored over there in the hard drive. This is row based. And in column based data structures, how data will be stored is first in the sequential manner is the name column, the sequence, all the rows of the name column, row 1, row 2, row 3, row 4, till row will be stored in sequential manner. Next, the ID will be stored. Column wise, all the rows will be stored in this particular structure. So this is how in columnar form, in vertical form, the data is being stored. So what is basically the reason behind storing the data in columnar form, or what is advantage of this columnar form data storage? This is how in Parquet file data is stored. This is how in CSV file data is stored. So when doing a single transaction itself, every time the new transaction or new row will be added for transactional databases. So it will be easy to put the new row in the end in such sort of CSV files. It will be easy to handle such sort of stuff. So, but in column-oriented databases, we already have the full data set available or full database available, which is archived and will be used for actually business intelligence. No new transactions are happening in that database. Understood? That particular database will be used just to analyze the previous business model, to have the insights from that. Maybe let us take a use case over here. We have a database actually having the transactions, and we store that particular database in a row-oriented form. And we'll be having regular transactions happening in that database up till and unless we have the financial year completed. When the financial year will be completed, we migrate that particular data from data row-oriented database to some column-oriented database, and then we can always use that historic database to have a visualization that bank will get to know that what are the people who had done the high value transactions, what are the people who had defaulted on some things, what are the people who have most of the amount, let it be more than 10 lakh in his account at every point in time. So by analyzing and visualizing that data over some BI models, made with Tableau. Tableau is a software used for business intelligence, or Power BI, which is Microsoft software. Then those softwares will be used to analyze and visualize that particular historic data, and will give brief insights that these 10 peoples are the one who are most valued customers. We can always offer them a loan of uh, made with 10 lakh rupees. So in this way, you have credit card offer, you are being provided a loan of 25 lakhs by the bank. This is how banks operate. So categorically, the two particular databases have different use case. One is for continuous transactions, and for that particular, this particular data structure, data row oriented suits best, because at any point in time, I need to add up a new row in the end, and that is very easy to end. And over here, when I want to analyze or visualize the data, then no new row is being added, or no new transaction is being happening over here. That particular database is now still, means no actual data transactions are going to happen. That particular data is being only used for visualizations. But the problem in this CSV or row oriented database is it has very low compression ratio. The size of database will be large, very large, because on the disk itself, when I will be saving, every of the column will have a different size. Maybe name, it is a string, and it will be having, let us suppose, 8 char or X. 8 means 8 bit. I'm supposing ID will be int. It will be having 2 bit. Number will be long int. May it be having 4 bit. We'll be taking such sort of sizes over the hard drive, and withdrawal will be having, let us suppose, 8 bit, and left will be having some 2 bits or anything. So when we will be storing these things in such form, so this block should be of 2 bit, this be of 8 bit, this must be of 4 bytes, this should be of 8 bytes. So this is heterogeneous in nature. So at any point in time, when I'll be compressing this database, it will be hard for the algorithms to compress in this fashion. So they'll not get a sequential sort of pattern how the things can be compressed. Now here you will be saving the data, all are of 2 bits, 2b, 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 2b. Then next will be all of 8 bits, 8 bits. So we have compression algorithms. What suits best on this use case? They can compress up to many folds. So that is why a Parquet file, similar, holding the same amount of data of as CSV file, it is 100 times smaller than a CSV file. We can store most of, I can say 100 times more data in Parquet data structure, Parquet files, or this column oriented data structure. So when the data will be hot enough, hot data means when transactions are happening. So at that point in time, for that year, we can always shell out more money on the cloud service providers, or we can have more database space available with us to have the hot transactions. Then we can always reduce the consumption of storage while having visualizations. So this will be cost efficient. Okay. And in this use case itself, one more thing, this will be fast for visualization. and this will be fast for transactions. Why fast for transactions? Because for each and every transaction, only the transaction happening will need to put a new row at the end of the database. It will be simple. For visualizations, what you need is you need a whole chunk of data. How can you what is visualization? Basically comparing the fields itself. Here for visualization, what I want is all the names of people in first go, then all the names of IDs, then all the numbers of amount they have transacted. So those whole chunks will be loaded into the RAM or the software, may it be visualizer or may it be Power BI or Tableau, in the bigger chunks itself to have the visualization. So that this particular use case fits over there. So it will fetch out the data in a faster manner. Okay. Now you understood what is column oriented and row oriented databases. Okay. Now coming on to here, you understood row oriented and column oriented databases. You got the idea of CSV, Parquet, column oriented data files. Fine. Afterwards, now coming on, you have basic idea of what BI is, business intelligence, Power
No, sir.
BI. So basically, as what I was saying in the example itself, business intelligence is nothing but basically to drive your business by getting the insights from data. Let us take an example. There is a bank and he want to open some new branches, and the leadership of the bank want to know what are the very suitable places where they can shell out their money and open new branches and will have the maximum profit. How can they do this particular? Either they can go blindly, either they can go blindly and say that this is my hometown. I want to give benefits to the people who are living near to me, who are my neighbors. So the leader will say that let us put up a new branch over here. May it be profitable or not. This is not the case. They need to basically, there is a requirement for them to satisfy the top directors or the whole management that what is the reason we are putting up a new branch and how that new branch will be more profitable. Why not to put it over there? So so this particular use case, they for this particular use case, they use or they leverage the benefit of their large databases, huge databases. In their all the previous databases, basically all the transactions will be depicting that what branch is highly overloaded, means what branch is having highest number of transactions, high value transactions, and most of the people, and what branch is having the most of the deadlocks or backlogs present with them. What branches are not able to cater the large amount of people or footfall which will be happening or which was happening over there. Okay. So now what they will do, they will get all these insights from the databases. Because databases are nothing, but they also have the, let us say, names along with the branch ID, where the customer ID is opened, how much transactions, what number of rows means how much transactions are happening there every day for last 1 year, one financial year, how much happening had done. So this all things needs to be visualized. This database first will be transformed into a column oriented, means this particular database is for transaction. This database maybe is operating on Oracle DB transactional version. Means for transaction, it is operating on Oracle database, which is a highly reliable relational database management system. Okay. Now, when the financial year is over, Now they'll do what? They will transform because to operate Oracle, it is costly. Operations of Oracle are costly because it requires more space, high power machines like Exadata, which can do the transactions fastly and efficiently enough. So to operate such sort of database is costly. So normally what they do, the data which will be old enough, may it be as per their company policy after 3 months, after a quarter, after 6 months or whatsoever, they transform or migrate that data to some sort of data warehouse. Data warehouse is what? Basically the the place where we can store structured data. Place where we can store structured data which is in the form of rows and columns. For mostly data warehouse is used for business intelligence purposes or visualizations. So now one thing is database which is hot and active enough to provide transactional queries. Another one is data warehouse, which can store the similar data in column-oriented form to feed that data to the BI tools or visualization tools. Now, the transactions are not regularly happening in data warehouse. They are merely a stop from where business intelligence or visualization tools can fetch the data from. So now my point was over here is we are discussing over here that if a bank wants to open a new branch over somewhere, so what he will do, the bank will do for previous quarters data or for previous 10 years data, he will set up that particular data into data warehouse, and then the BI tools which are capable enough to get the intelligent information extracted out of the previous data by implementing some sort of rules. Means what I want to know. By implementing those rules, it will create some sort of visualization that this branch, these are it will be called data transfer after data transfer transformations and fed it onto the visualization tool. Then we will be have a graphical structure like this created using the previous data, that these are branch number 2, branch number 3, branch from 5 in that country, and afterwards cities, Jammu, Delhi, Bangalore, or Mumbai, all the branches from there, how many transactions will be happening. So this will be creating a visualization of the previous data that's on those particular cities, number of clients are such, the amount of transactions happened is this, the total amount of the total cost of the whole transactions will be some X amount in a visualized form, and what branches are overloaded over there. So what they'll be doing, the near to that branch itself, which is overloaded enough, they'll open a new branch. They'll get a idea from that by using the BI tools and visualization tools that what to do in the business next to have the highest operational profit. Now you understood, Prakhar, what basically business intelligence is? Prakhar, you there? I think he is not available. You all other people,
Yes,
you
sir.
understood
Yes, sir.
what BID?
My mic was.
Okay. Now you understood now what basically this business intelligence is,
Yes, sir.
what data analysis is, what data visualization is. Now you understood these concepts.
Yes, sir.
Okay. Now while discussing this, we had got insights that what is hot data, what is transactional database, why the operational costs of transactional database are high, why to use data warehouse instead of database? Because data warehouse normally will have column oriented data which will be fed upon for business intelligence purpose. Understood this? Now this is clear. Okay. Now the question is how to migrate a database from a row-oriented data structure to column-oriented. May it be how to transfer very large amount of data from Oracle database, may it be to data warehouse, which are heterogeneous. Heterogeneous means not of similar form. Storage underlying storage structure will be bit different. Okay, how to do that particular thing? And in my case itself, if I want to transfer a file from one folder to another, what I do is on my laptop, I copy that file and then paste it into another other location. And if I want to transfer that file over the network itself, I use previous FTP, may it be NFS or other technologies to transfer the files. This is how we can operate the transfer of file in small scale. Perfect. What if the size of data relates to the terabytes or petabytes? Our processors will fail. They'll not even be able to get the structure of files or number of files. They'll be calculating for the endless time that this much, maybe billions of files needs to be transferred. Smaller CSV files or smaller FASTA files. So our processors will not be able to even calculate the number of files needs to be transferred. Leave apart that they'll be able to transfer it or not. Okay. So our small machines or those structures are not meant for such purpose. Okay. To transfer huge amounts of data from one place to another, we use terminologies ETL. Okay. Understood? What ETL is? Extract, transform, and load. This is the main core work of data engineers. They are supposed to do ETLs, to transfer large amount of data from one place to another place. Understood? No? So to achieve this process of extract, transform, and load, wait a second. Just wait a second. Nice. You are getting a lot of noise from behind me,
No, sir.
or it is okay for you? No noise disturbance.
No, no, sir. No noise.
Continue from this. Okay. So what I was saying is to achieve this ETL, extract, transform, load. What ETL is? There will be a source from where we will be copying the data or extracting the data. May this source be some database? May that source be some IoT device which is continuously pumping the raw data somewhere? May it be some sort of data warehouse previously from where we need to transform the data to other place. So there are different sort of type locations what from where data can be extracted. Now transform term I'll be defining you or giving you the brief in a while, and the destination will be may it be data lake for IoT device data and unstructured data, may it be data warehouse, or may it be database. I want to migrate the databases, or may it be some sort of blob storage or some sort of other thing. And here also we can have blob storage as the source itself. So in nutshell, if I'll I'll not talk of transformations part at this point in time. Then E and L means to copy and paste their data. To have data from somewhere and to put it over at other place. Okay. Transformation is also very important, but will be to do such sort of transformations or such sort of extraction and load in Azure, we use Data Factory, which is a GUI based system, graphical user interface based system, where we need to drag and drop some of the boxes. Maybe for extraction, we need to have some data source defined. We need to drag a source file and we need to put the information of from where and the credentials from what blob storage, what are the secure credentials to log in into that blob storage so that we can have the access of the data of that blob storage, maybe key or so. So this is how Data Factory works. Just write down these words and in the free time, Google upon over these things. Write out what Data Factory is. Google it out afterwards that how these things. It is Azure's data. Another one is Data Factory has one of the benefits, which is you need not to know the programming languages over there. You may not be knowing SQL itself. Just drag and drop the things, put the credentials over there, and the things you are good to go for ETL sort of thing in Data Factory because that is GUI based. And but one thing is you will not be able to custom tweak the requirements. Custom tweak the requirements if the transformation needs expertise. Like you want to transform the data. First, I'll be explaining you what transformation is. Then I'll be coming on. Just write down for that point in time. One is Data Factory. You need to serve. This is Azure service. Another is Databricks. This is a big company, which is basically $1 billion company, we can say, but is dealing in big data ETL systems. In that, we need to use language, maybe Scala, PySpark, SQL to write the code itself for transformations and all. Rest, you need to put in the code itself that what is the source and what will be the destination itself for the data, what needs to be traveling. Okay. These are cloud available over Data Factories on cloud, Azure cloud. Databricks can be spun upon on-premise and is also available on all the major cloud service providers. Okay, like it will be available on AWS, it will be available on Azure. For on-premise only ETL systems, we use a software named Pentaho. Function is similar. Extract the data, to transform it, and then to load it. And now comes the term transformation. What transformation is? Transformation means if we will be having, let us say, two different tables or two different databases being sourced from somewhere, or in a single database, we will be, we can say, getting the data from two tables. And what the business intelligence platform needs is it needs some bit different sort of schema, what it can visualize. Like if I have maybe two tables, I want to concatenate those tables and drop some of the columns which will not be used in the visualization. We want to travel minimal data and clean data basically. All the data which is not necessary for visualization software will drop that. Means the whole columns will be dropped. The null values of the rows will be dropped. The rows will be cleaned for actual data which can be worked upon on the data visualization software. Because if you will be feeding null values to the BI software, it be Power BI or Tableau, it will give you ambiguous results, not proper results. It will not be able to analyze the data in the first place. So what we want here is we want to clean the data at the central state. Means at this, from the source itself, we want to load the cleaned data. And one other use case here is if I have two different tables, we can always concatenate those tables, join those tables while transferring itself. While the data is being transferred, it is being transformed into some other sort of data structure. Maybe its schema is changed, some columns are dropped, two of the tables are joined, a new table will be created in between, and then the final table will be loaded into some data warehouse, which can be consumed by the Power Visualization or you can say uh, visualization softwares or BI teams softwares. Okay. Now you understood what transformation is and what is purpose of transformation. It is written over here. You understood that particular purpose? Why we need to
Yes, sir.
transform or clean the data itself. Okay.
Okay, sir.
Now again coming on to ETL itself, extract you know, load you know. Now this particular thing is process and compute hungry. Transformation is process and compute hungry means when we want to drop some tables, we need, or when we want to clean some of the rows, we want to you can say shell out the null value. So for that purpose, the most important thing is we need to first analyze the data. We need to read the data row by row, column by column. Each of the data should be first read, and then we will get to know about that this particular value is null value, and we will be purging that row also. The bad rows will be purged. So for all this to happen, we need a lot of compute power. Let us take an example for big data. If I have 100 billions of rows in a database, which is quite a possibility for maybe the database of 100 terabytes or 1000 terabyte database will be having more than enormous amount of billions of rows. That is why that particular database is that new. So to analyze or to just go through those billions and trillions of rows, we need a hell lot of computing power so that we can get to know that what particular fields are rogue, what are having null values, what of the basic rows needs to be dropped. Then again, SQL command will go on and it will find that these particular rows will be having null values, and then a SQL command for dropping those where, like SQL from the table where the row is null, drop. This will be format of the SQL command will be writing. So now one thing is understood over here. We need hell a lot of enormous computing for power for the transformations of big data. How that can be done? No, my single laptop will not anywhere. It will be sort of a sand particle in the whole universe of computing power. So what I need is a cloud-based, large VM-based cluster of processing. A cluster what can process the data in most efficient way. And here Spark comes into picture. Just go and Google what Spark clusters are. Spark is basically providing a GUI-based data factory. Spark is basically doing what? It is creating a cluster of highly powered compute machines, may it be on-premise or on cloud. Databricks also underlying uses Spark for the transformation purposes. Underlying they'll be using Spark clusters. So Spark cluster can basically we can have Spark cluster with few worker nodes if the load is small. Means if the data set needs to be transformed is not that big, we can have 10 node cluster. So we'll be having 10 worker machines working simultaneously, and they'll basically split out the data in a fashion that each of the machine will have is a quantifiable number of rows to deal with. So they'll do one thing, smart thing. They'll split up the billions and trillions of rows into the multiple values, and they'll have a smaller chunk for each machine allocated. So Spark cluster can be of 5,000 workers, 5,000 nodes, 10,000 nodes, depending upon how large our data is and how fast we need to process it. We can always have bigger clusters. What will happen there is Spark clusters or parent Spark will distribute the data towards the worker machines. Which number of rows will be quantifiable enough so that each worker machine with the specific specification means RAM as well as processing power can able to handle that particular data set. So each will be doing their performance. They'll be cleaning there, and in the end, all things will be concatenated enough and will be loaded onto the may it be data lake or data warehouse, or the clean or transformed data will be transferred to some other destination place. Now you understood what this particular Spark cluster is and how that particular cluster is beneficial, or how that particular cluster is performing the transformations. Basic idea. Got that? Okay. Underlying on Data Factory itself, Data Factory is also using Spark cluster. It is relying upon Spark clusters to transform the thing. May it be GUI based. The thing, the only difference between Data Factory, Databricks, and other is Data Factory is GUI based, where you need to give your specifications. Like I want to copy, or the source is having two tables, and I want to transform or I want to drop these maybe columns. All those things will be clicked on upon in Data Factory. Okay, we need not to write any code, but in Databricks we need to use SQL commands. SQL commands or other languages like PySpark, Scala, or any other. Scala is also a language. Where we can, in that particular language, we will be writing code. In that code, it will be saying that extract so and so table from that location. We will be putting up credentials over there, and afterwards, what transformations we want. Need to drop what tables, need to join what tables. We will be writing the SQL commands over there, and over where, what place the cleaned data needs to be loaded. Now you understood the whole terminology here. What ETL is, what Data Factory is, what Databricks is, okay, what GUI is. Just any one of you just write down these terminologies what I told you to Google upon over here in chat itself, so that others can also leverage the benefit. Write out Data Factory, write Databricks, write Spark cluster. You need to search on Google for these things. Okay. Row-oriented, column-oriented databases. Just write it out over there in chat. Afterwards, data cleaning. You understood the terminology, what data cleaning is. You know what schema is. You know what structures like integer char I had, what visualizations are, what databases are. Okay. CSV. Okay. Now, while using the transformations or so, while using the Spark cluster, what normally in Databricks we do, where we write code, we write the code on some notebook. You must have heard of Jupyter Notebook. Anyone of
Yes,
you
sir.
have heard of?
Yes, sir.
Have ever used that Jupyter Notebook? And if used, for what purpose?
I have used for
IPM,
exploratory data analysis.
Yes, also
Okay.
used for that.
That is something. So normally in Databricks itself, we write the codes in Jupyter Notebook, and codes will be maybe written. Sometimes we write it in SQL language. Sometimes we use Spark. Sometimes we use, because all these languages are being uh, Databricks can basically do the transformations if we can write code in any of the languages. So then Databricks is available for all these languages. Okay. What data frame is? Data frame is basically a intermediate place on Databricks platform over where the data is being first loaded, then Spark clusters work upon that data frame, clean it out, and then actually the data of data frame is then transposed onto some data warehouse or lake or the destination place. So intermediate place where data is being worked upon. In data sets you understood, data warehouses you understood. Okay, now what is data lake? Data lake, as in Azure, you have heard of as data lake Gen 2 or Blob itself. What data lake is? Where we can store unstructured, semi-structured, or structured data. Anything we can store over there in data. Data lake can have image files. Data lake can have video files in it. Data lake can have structured tables or CSV files, Parquet files also in it. But in contrast, data warehouse will require structured data to be fed upon onto the data visualization mostly. Softwares also. Okay. Data engineering. Okay. That is what I give you insight of what data visualizations is. Old data collected to improve business requirements. Data transfer to BI. Okay. To write a code, we use normally SQL, PySpark, etc. For transformations of using Spark database. GUI based transformations. Okay. We use Azure Data Factory. Blob, data warehouse, database. Okay. Sources. Now we will be afterwards coming on to the IoT. Basically, we have studied the use case of databases. Normally, ETL works with what we studied is the chunk of data, videos, images, also. So, in real world, huge amount of data is continuously being generated by IoT devices. What are IoT devices? You know, any of the IoT devices?
A device which is connected to the internet and store data.
Can you name any of the IoT device what is being used in our day-to-day life also?
Google
Cameras.
Home Mini
Yes. Yes.
and Alexa.
There is also IoT device. Can smart
Mob.
cameras come under IoT device category?
Yes,
Smart
sir.
cameras.
Yes, sir.
Yes, because those are connected to the internet all the time and they are feeding upon. May it be messages, may it be notifications, may it be alerts of motion alerts to our mobile phones over some channel, and they are also feeding up the video files or to the cloud for intelligent analysis, video analytics. Okay, so this is also IoT device. So before coming on to IoT device, I want to show you now one thing. Hmm. Let me present my screen over here from laptop. My screen is visible.
Not yet, sir.
Now it is visible.
Not yet, sir.
Now visible.
Yes, sir.
I copied some of the examples from Databricks to show you. Read the right. Okay, that's cool, sir. Let's see. So these will be some sort of codes what we will be dealing in Databricks. This is how we write normally. The purpose of showing you this is how notebook looks like. In Databricks, we will be creating a notebook. We will be having a sample notebook also. This is how we can comment the sections, or we can have write the comments. Like in code itself, we comment the things for help of other. Here we have blocks. We can write what to do, like help. And these are actual code snippets. What are the credentials? What is the key? How we'll be communicating to those things? What are the port numbers? This is actual code. How connection properties are being driven off? What JDBC is, Java Database Connector, will be using for connecting to some sort of database. We use JDBC or ODBC. What are the URLs? What are the various tables we need to deal with? Spark need to read this particular thing. What is this DF? DF means data frame, what I was speaking of. We need to copy that particular thing into the data frame. or actual transformations. So these are the various things. For data engineering advanced courses, you will be learning such sort of SQL queries also. Okay, got it? Let me say. Now, new terminology also had came into the picture a few years back. That is data lake house. It is a place where we can pump in structured, unstructured, and semi-structured data. And after loading the data into the data lake house, we can always transform it into some sort of intelligent structured one. We can convert it into delta lakes, data lake to delta lake, which can be transformed into warehouse sort of structure, upon which the business intelligence tools can also leverage that. Write one more thing. Quick study about what data lake house is also. And also comment this particular thing in chat box. Data lake house. Okay. Write it out on the comment box. Anyone. This is how delta table will be created. These are the schemas. So purpose of showing this is to just hypnotize you with the thing how these are stored in Parquet files. We can always deal with JSON files over here. We can deal with CSVs over here. How to deal with such files? How to read from delta tables? This is data frame. These are commands. Spark.read.format. Okay. Give you basic understanding what you people will be going through in the advanced levels of code. Good. Now again, we'll be switching on to my okay. Now has shown you how actually codes are being written in notebook formats. Listening, no, again, there are two types of major databases. One is SQL, relational database, and another one is NoSQL database. You understood what NoSQL database is?
Non-labeled databases.
Anyone of you have heard of Cassandra? MongoDB. MongoDB. Heard of that?
It's a non-relation database, MongoDB.
Yeah, the database what stores the data in form maybe made in MongoDB. It stores the data in form of JSON files in MongoDB. It is not storing the files in a tabular structure or tabular format in rows or columns where the transactions can happen. But it is storing the data in some sort of file structure. Means in MongoDB we use JSON files to store data. Okay, so basically the images, the videos, and other sort of files can be stored efficiently in NoSQL databases. They may be key value pair, there may be some sort of file storage stored. Okay? Like Instagram and Apple itself for their app store, which is storing a lot of executable files. Even Play Store, which is storing APK files, Apple as well as Apple Music, which is storing the audio files of music, as well as Instagram and Facebook, they are using Cassandra as a database to store the huge amounts of video, audio, images, and all other files. So they are not transacting anything over there in the database. There will not be any transactions happening in the NoSQL database. Okay. In NoSQL database, we are basically doing what? We are storing the images, and upon the requirement, we are retrieving the images or videos from that particular database for consumption to the social networking sites itself. So this is the use case over there. So we don't want acid properties. Means we don't want atomicity of the transaction over there. Atomicity means either the transaction steps, all transaction steps can be happening fully, or if in any middle stage the transaction loses, the whole thing should be rollover or back over to. You know what particular ACID transaction is? What transactional databases main theory means, what actually transaction is itself. Any one of you understand that particular concept? Transactions. Any one of you know anything about this particular ACID or transaction? No.
So the rough idea is that it relates to concurrency, that a set of tasks that are like given to the database, and each has to wait for other, and without the loss of any record. That means like multiple records can be written at same time, but one has to wait for the other to complete and be written or edited. So
Like, yes, sir.
No. Yes.
So basically, I
Go
want
on,
a
go on.
deadlock condition, and the separate tasks will be separated in isolation fashion.
Perfect. No, to be in very layman's language or in a very rogue way, I can say, if a bank transaction is going to happen, maybe of um, withdrawal, withdrawal of money from ATM. So this is a sort of transaction in bank, withdrawal of money from ATM. What will happen in the background? What happens is there must be some multiple number of tables. Will be holding the data of the customer as well as the bank account. Let us take for simplicity, 3 tables are there. One table is responsible for having the data of data of the customer made with name, ID, and made with total amount in all accounts, all the saving accounts as well as made with current accounts operational, to have a whole picture of where the user stands. Means, is the particular user gold user, is particular user silver user, or bronze user as per the bank's category. One table will be like that. Another table will be storing the data about saving accounts. Saving accounts. So it will be having name of the person, ID of the person. On very rogue way, I can say it will be having total amount in the saving account, then date, time, will be having transaction. Means amount of transaction credited, and another one will be transaction debited. These sort of tables may be transaction credit, and maybe third table will be for transaction debit. Let us take an example. For transaction to happen successfully, we need to update all these tables concurrently, one after other, and the whole transaction, complete transaction, will be the transaction will be um, meant to be completed, or will say that whole transaction is now complete only when all the tables without any flaw or issue will be updated successfully of latest data. If in any case, when transaction will start, first let us say saving account table will be changed, like modify or insert query. Insert query will be given over here. A new row will be added, maybe modification, or a new final amount will be different over here. Then we want to update the second table where whole of the total of all the accounts will be there, maybe saving as well as credit account. It needs to be modified, or you can say new row will be inserted so that final amount will be different here. And then we want to update the third table. May be some, in some case, after updation of first table, the server goes down. The physical server holding the table may be will be unavailable, and the transaction is not now complete. Now, in that case, there will be some sort of cache memory or so, what will be taking track, track of what transaction has done till now. So if the transaction is not fully complete, then upon retrieval of the hardware, it will roll back the other steps what were done earlier in half transaction. So it will roll back the final step, and made this can happen after 1 hour. Now the money is actually not transacted out of ATM, and here in ATM it is written transaction declined. So if they had given out the money, and in the final after 1 hour the system will be up, they'll be getting that such sort of transaction is not possible because this amount is not actually lying in the credit amount or the total amount. Then how will they be able to retrieve that amount from the customer itself? So it will be wise normally to roll back the transaction and say bluntly to the customer the transaction is declined, and do this sort of thing. You understood now what this particular transactions are? Set of small actions what can be rolled back if unsuccessful. Okay, understood? Anyone?
Yeah, sir.
So, sir, you are basically talking about the acid properties of a transaction.
No, yes, I am basically coming on to the acid property. Acid means atomicity, consistency, isolation, and durability. Just write down in the chat itself, anyone, this acid. Go through this acid also. Acid versus CAC. Okay. So I am talking of this particular thing over here, that for transactional databases, they need to comply with ACID properties. And for NoSQL databases, they need to comply with CAP theorem, which is consistency, availability, and partition tolerance. Because the NoSQL databases will be holding enormous amounts of data, maybe in the scale of petabytes. Like Instagram's data is 200 petabytes, and Apple's database is largest, which is being handled by Cassandra, which is a NoSQL based data base system. So that is the largest database available in the globe also world. So to handle such sort of databases, which are of the scale of petabytes, no single machine can be used. So we want to distribute the data among the nodes. So NoSQL databases like Cassandra normally work in node fashion. That actually the tables are partitioned into various subsets, and different partitions of a table are being stored onto the different nodes. Nodes are nothing but physical hardwares, servers. Is to store bigger databases like database of Cassandra. We want thousands and thousands of nodes. Nodes means physical machines over where the actual tables, bigger, larger tables, are partitioned and are being stored in a distributed fashion. In Cassandra, we call this as data center. These are there is a concept of racks over there also, and the concept of nodes, where actually the smaller partitions of a table are being stored. And to have the high availability, we have the concept of uh, what we can say. We have multiple copies of similar partitions stored on different nodes. Replication. So we replicate the data over there in Cassandra. So to deal with the distributed databases and to have the data consistency means whatsoever written over at some node should be the only thing whatsoever will be retrieved. Means there must not be a false data output or stale data. Stale data means if I have stored something and after the few point in time I had updated that data, and I'll be getting afterwards when I'll be querying the data again, I must not be getting the previous data. I must be getting the final updated data. Means the data should not be stale. So those all things are the problems when we are actually handling the distributed databases, because at any point in time any node can go down. This will not spindle upon the whole database working, but that single partition will not be available. So for that we use replication or all other factors. So their cap theorem comes into picture. Means partitioning means we had partitioned the table data. Availability means once they are required, the nodes should be available. And consistency means the actual data should be retrievable. No stale data, no false data. So this is the basic underlying pillars of NoSQL databases. So we will be covering these things in future classes or advanced lessons itself. So just for your understanding, I have given you a basic concept of what various different types of databases are. One is ACID, and the one is CAP theorem based means NoSQL database. Okay. Now, coming on to a use case over here. How many of you know what AGI is? Should we discuss this particular thing? Because I believe you must be exhausted after, I believe, 2 hours of sessions. If you want, we can always have this discussion separately, because this is a separate discussion. It will take me time. We can always discuss it tomorrow. Or okay, that is fine. For today, it is fine. You people got the basic concepts of basic ideas of what data engineering is, how to deal with data,
Yes, sir.
what are the various different types of databases. Just for your reference itself, go through CAP ACID or go through NoSQL as well as transactional databases. Write the things down. And if in any case you have any doubt regarding the data engineering or data pipelines, or you can say data transformations or anything, just ping me out. It's apart from that, you will be covering all these things in detail in the advanced sessions taken by SQL team also. This was just for your mere basic understanding at what data engineering is, what you will be facing upon in the industry, what are the various terminologies, what you will be stumbling upon. From this session, I have given you various of the terminologies and asked you to Google it out. Just Google them out, have the basic knowledge of them, so that you can get to know how actually data engineers are working in the real world projects. Okay, fine. So, any question for now? So we can always wind up for today. So before that, I'll be giving you a next set of Linux tasks, uh, maybe 4 or 5 tasks today for Linux only or infra, not for this SQL or so, because those tasks will be given to you by the respective teams only. So I'll be giving you Linux tasks, and just everyone prepare a document of those tasks along with the screenshots whatsoever you had done, like today man had done, all the good initiatives I can. So just all should prepare the document with all the tasks along with screenshots. Okay. And you need to submit all those documents in this chat itself tomorrow. Okay. Perfect. All well. Thanks for now. Bye.
Thank you, sir.